Welcome to all. This topic going to give details about supersaturated flow or metastable flow through nozzle. When dry saturated steam is expanded adiabatically or isentropically, it becomes wet and is shown by a vertical line on molecular diagram. In generally, the molecular diagram of TS configuration, the vertical axis represented in the temperature and the horizontal axis will represent entropy. In the topmost curvature line denoted as saturation line, and Wilson line also parallel to the saturation line. In between the Wilson line and the saturation line is called supersaturated region. The left hand side curvature represented the pressure values, pressure 1, pressure 2 and pressure initial. Likewise, the HS diagram, the enthalpy versus entropy diagram is also showing that the saturation line as well as the Wilson line in between represented that region is supersaturated region, where we can see the decrease in heat drop as well as increase in entropy from first stage to next stage, maximum to minimum. In that way we can calculate that decrease in heat drop as well as increase in enthalpy. The middle curvature line is represented that pressure, different pressure value of the steam. Because of this we can able to analyze and taken out the required point of character. If the steam is initially superheated, the condensation should start after it has become dry saturated. This is possible when the steam has proceeded through some distance in the nozzle and in a short interval of time. But from practical point of view, the steam has a great velocity, sometimes supersonic and even supersonic. Thus the phenomenon of the condensation doesn't take place at the expected rate. As a result of this, equilibrium between the liquid and vapor phase is delayed and the steam continues to expand in a dry state T. The steam in such a set of conditions is said to be supersaturated or in metastable state. It is also called supercooled steam as its temperature at any pressure is less than the saturation temperature corresponding to the pressure. The flow of supersaturated steam through the nozzle is called supersaturated flow or metastable flow. Here we are going to discuss about effect of supersaturation, where the following effect in a nozzle in which supersaturation occurs are important from the subject point of view. Since the condensation doesn't take place during superheated expansion, so the temperature at which that supersaturation occurs will be less than the saturation temperature corresponding to the pressure. Therefore, the density of supersaturated stream will be more than for the equilibrium conditions, which gives the increase in the mass of steam discharged. The supersaturation increases the entropy and specific volume of the steam. The supersaturation reduces the heat drop for the same pressure limits below that for thermal equilibrium, hence the exit velocity of the steam is reduced. The supersaturation increases the dryness fraction of steam. Within this, I will conclude this presentation. In the continuation will be on next part. Thanks for watching.